Hello, this is Vedant Rai, SAP ID 60001180061 from B4 batch of TE Electronics. Today I will be presenting experiment number 5 of my DLIC practicals. The aim of this practical is to design two voltage to current converters. The first one using a floating load and the second one using a grounded load. As we can understand from the terms of floating load is one which appears to be floating in the circuit. It should not be connected to the ground. We have derived its equations and we have got IL equal to Vn by R. This leads us to believe that the load current is independent of the load resistor RL. It only depends on the input voltage and the resistor R. Then we'll see the grounded voltage to current converter. In this you can see RL is connected directly to the ground. From its equations we can see that IL, the load current, is equal to V input upon R. It again leads us to believe that the load current is independent of the load resistor RL. We'll now see the circuits. We'll first see the circuit for a floating VI converter. This is a circuit for a floating VI converter. We have calculated the values. We have assumed the values of V and IL and we have got the value of R equal to 250 ohms. In conventional resistors, these are 220 ohms plus in series with 33 ohms. And yeah, we have put it here, the 220 ohm plus the 33 ohms. The load resistor I have taken as 2K for now, and the input voltage is 1 volt. I'll now run this circuit, and I have got the load current equal to 3.95 milliamperes. This is the value we are expecting. I'll now change the input. I put it as 5 volts and I run it. Then you can see that the output has become 5.99, which is what we are expecting. I'll now put it back to 1 volt, run it, and according to our calculations, the value of IL should be independent of the load resistor. We'll now check that hypothesis. It is currently 3.95. I'll make the load resistor 50K and the value has changed to 279.795 microamperes. This is against what we had thought earlier. I'll now show you the grounded VI converter. This is a circuit for a grounded VI converter. The 250 ohms resistor is divided into 220 and 33, 220, 33, 220, 33. I've taken the input as 1 volt and the load resistor I've initially taken as 2K. I will run this and I get the load current 2.563 milliamperes, which is what we are expecting. I'll change this value to 5 volts input, and when I run it we will get a different value, which is 3.9125. Now I'll check if the load resistance is affecting the value of the load current. I'll change it from 2K to 50K. The value currently is 2.56 and I run it and I can see that the value has become 111.84467 microamperes. Again, our hypothesis of IL being independent of RL has been proven wrong. We can conclude that these circuits we have built, they produce the output, but they are not perfect. They cannot be used as in serious applications. We need more better industrially built ones, and I will now show you the circuit diagram for a XTR111, which is a precision voltage to current converter which is used in industries. There are no resistors in the circuit. Instead we have MOSFETs, and here this is the external resistance R set, which is used to set the value, to adjust our value. And as I said, we are using MOSFETs instead of the resistors, and yeah, that's all. And we get the value of IO, we find it to be equal to this 10 VN by R set. So it is independent of any other resistance and only depends on the input voltage and the external resistance R set. In this circuit it will work properly, and even on changing any other resistance it should not affect the output current. That's all for this experiment. Thank you.